Greetings of the day, dear students. Today in this class we are going to discuss about the one of the important transformation, that is delta to star, right? And where you are going to have some problems, right? And also we will see or discuss about the star to delta transformation. Here in this scenario we will discuss what do you mean by this delta connection. By the time you complete this video, we will discuss what do you mean by delta connection and what do you mean by star connection, and also how to transform the given delta into equivalent star. If a delta is given, what will be its equivalent star, and also we will do step-by-step analysis to find out the derivation, to find out the equivalent value. All these steps we will discuss in this video, and like this we will find out R2, R3. At the end we will have the summary, right? Delta to star, and also we will discuss the examples in this video, right? So this is what we are going to learn in this video. By the time you complete this, you will be able to solve the problems on delta to star transformation. Okay, right? Yeah. Now observe, dear students. For example, already we have discussed the resistors connected in series and the resistors connected in the parallel, how you are going to find out the equivalent resistance. Sometimes the resistors will be connected in such a manner that they are neither series nor parallel. Neither series nor parallel. Then if it is not series or if it is not parallel, some two other different possibilities are possible. What are those? One is the delta connection, right? The other one is the star connection. Now when we will say the resistors are connected in delta manner, how you can say, by looking into the circuit, how we can say that the resistors are connected in delta manner? The thing is simple. For example, if you are having three resistors like this, let me name it as R12, R23 and R31. If one end of the resistor, if second end of this first resistor is connected to the first end of the second resistor, this like this the connection is made. Second end of the first resistor is connected to the first end of second resistor. Similarly, the second end, this is the second end of second resistor, is connected to the first end of the third resistor. So far clear? Now the second end of third resistor is connected to the first end of first resistor, like this. If such kind of connection is made, then it is called delta. It is connected in a delta manner. Very simple. Similarly, if it is star connection, what we will say is one end of each resistor will be joined at one point or connected together to form a junction point. For example, we are having three resistors, R1, R2 and R3. For all the three resistors, one end is connected at one common node or at a common junction that forms a junction. Then it is called star connected. So far clear? Okay. Now let me see the transformation. What do you mean by that? For example, if a delta is given, you can draw this or transform it into an equivalent star, right? Like this connection we can make. But after transformation, what should be the value of R1 in terms of R1, 2, 2, 3 and 3, 1? How much should be the value of R1? Just like in our source transformation, the rule is simple. A voltage source, okay, in series with a resistor, like this, some positive negative voltage source is there, is transformed to a current source in parallel with a resistor. Statement wise, very simple. Now the next question arises, what should be this value of current, or what is the value of this current we have taken? V divided by R. Similarly, while transforming the given delta to the star, what should be the value of R1? How much it should be in terms of R12, R23, R31 we have to express. right? Dear students, observe. For equivalent transformation, what happens is the resistance between the two terminals must be same in both the types of transformation. How do you understand that word? The after transformation, the resistance between two terminals must be same. Its meaning is, if you are having a delta like this is at node 1, node 2, node 3. Resistor between 1 and 2, name it as R12. Resistor between 2 and 3, name it as 23, and between 3 and 1, name it as R31. If it is transformed to the star, now this same 1, 2, 3 must be same. These 1, 2, 3 nodes must be existing. And now this R1, which is in between the first node and the neutral or zeroth node, between 1 and n. R1. At second node to neutral, name it as R2. Third node to neutral, name it as R3. Right? Now whatever the equivalent resistance looking into the circuit between 1 and 2 must be same as equivalent resistance between 1 and 2 in the star manner. That is very, very important. This is the first step we should remember to do the transformation. I repeat again. While looking into the circuit, okay, the equivalent resistance between 1 and 2 in this delta circuit must be same as the equivalent resistance between 1 and 2 in star connection. Now let me find out equivalent resistance between 1 and 2 in the delta. Observe, you remove this white. Now R31 and R23, we have just simply drawn the straight line. This one R31 and R23. These two are in series. These two are in series. This is what we have written here. And this entire thing is parallel to R12. Clear? Now we know when two resistors are in parallel, what is the equivalent? For example, R1 or RA parallel to RB, then what we will say? Equivalent resistance. R equivalent will be, okay, RA into RB whole divided by RA plus RB. But in the place of RB here, what is there? This is simply RA, just like RA, and in the place of RB we are having this one, right? That is what we have done here. R equivalent between 1 and 2, between which two terminals? 1 and 2. In which connection? Delta connection. So R equivalent between 1 and 2 in delta is given by R12 into R23 plus R31 whole divided by total resistance R12 plus bracket of R23 plus R31. Now let me consider this as the first equation. So far clear? I repeat again, dear students. We want to find equivalent resistance between 1 and 2, between 1 and 2, looking into the circuit. If you observe, 3-1 and 2-3 are in series, and the entire combination is in parallel with R12. That is what we have written here. R12 parallel with R23 plus R31. Now we know from the basics, if two resistors are in parallel, equivalent resistance is RA into RB whole divided by RA plus RB. That is what we have done here. Now come to the equivalent resistance in star connection. You have to look into the circuit. Observe, current came up to here, it is flowing like this. So R1 and 2 are in series. So that is what we have written here. R equivalent between 1 and 2 in which connection? Star connection. R equivalent between 1 and 2 in star connection is equal to R1 plus R2. R1 plus R2. Clear? Now for the transformation to be equal, this 1 must be equal to 2. 1 and 2 must be equal. That is what we have done here. For delta to star transformation to be equivalent, 1 must be equal to 2. Equate 1 and 2. And let me take it as some third equation. Now the same steps are to be repeated to find equivalent resistance between 1 and 2 is completed, no? Next possibility is there. Next possibility is between 2 and 3. Next possibility is between 2 and 3 we will find the equivalent. Next possibility is between 3 and 1 we will find the equivalent. Such kind of steps 3 times we have to repeat now. Clear? First time we have found out the R equivalent between 1 and 2. Now we will continue to find R equivalent between 2 and 3. Right? Yeah. Now let me redraw the circuit. For example, if I want between R equivalent between 2 and 3. Observe, dear students. This is third terminal. This is second terminal. This resistor is there like this. Now the remaining 2 resistors are in series. These 2 are in series. And that resultant is in parallel with R23. That is what we have written here. R equivalent between 2 and 3, in which connection? Delta connection, is equal to R23 parallel to the series combination of these 2. Now these 2 resistors are in parallel. Same steps. R23 into bracket of R12 plus R31 whole divided by R12 plus R23 plus R31. Clear? For all these things, the basic you should know is, if 2 resistors RA, RB are in parallel, then the equivalent R equivalent will be RA into RB whole divided by RA plus RB. This basic is very, very important when 2 resistors are in parallel, right? Yeah. Now observe, these 2 resistors are in series. You are looking into the circuit. You are looking into the circuit like this. You have to look into the circuit. Now R3 and R2 are in series. Same current flows. R3 and R2 are in series. So R equivalent between 2 and 3, in which connection? Delta star connection, is equal to R2 plus R3. Now this 4 and 5 must be same. Very simple. That 4 and 5 must be same. Similarly, we can find out 2 terminals are completed. Now R equivalent between 3 and 1. We have completed. R equivalent between 1 and 2 is completed. R equivalent between 2 and 3 is completed. Now the third step is R equivalent between 3 and 1. If it is 3 and 1 between here, this is the first terminal, you have to redraw the circuit every time. The only thing you have to require is remove here on one wire is there, you remove that. So now these 2 are in series. Looking into the circuit, we can say these 2 are in series. You add these 2. That is what we have done here. And this combination is in parallel with R31. Now these 2 are in parallel. So RA into RB whole divided by RA plus RB. Now for the transformation to be equivalent value between 3 and 1 in star connection is, observe, these 2 are in series, R1 and R3. There is no any other tapping. So R1 plus R3. Now 7 and 8 must be equal. So dear students, at last we are having 3 equations. One equation we are having in terms of the first equation we are having, and the last one is we are having in terms of some R1 plus R3. And what is the second equation we got? R1 plus R3 we got. R1 plus R2 we got. We are having equations in terms of R1 plus R2, and we are having equations in terms of R2 plus R3, and we are having equations in terms of R3 plus R1. R3 plus R1. Now we have to do simplify. Just for example, R1 plus R2, for example, if you substitute R1 plus R2 minus R2 plus R3, what we will get? R1 minus R3 we will get. And by adding R1 minus R3 with R3 plus R1, we will get one step. At last, using these 3 equations, your target is to find out R1 equal to how much, R2 equal to how much, and R3 equal to how much. That is what we are going to do, right? Observe. See here, from 3, 6 and 9, you just let me separate 3 minus 6. 3 minus 6. For example, the equation which we got in terms of R1 plus R2 is given which number? R1 plus R3 is given 9, no? This is given 9. And this is given 3 in terms of, and in terms of 2 and 3 we have given it a number 9. Now what he's saying is, in the first step, 3 minus 6. R1 plus R2 minus R2 minus R3. R2, R2 cancel. R2, R2 cancel. Now we will get R1 minus R3. But we want R1 and R3 separately. What we can do? We can add this R1 minus R3 with 9 by adding 9 and 10. What we will get? 2 times R1 we will get. Why? Because one is R1 minus R3 we got, the other one is R1 plus R3. We are adding these two. So 2 times R1. 2 times R1 we will get. So 2 times R1 is equal to 2R12 R31 whole divided by R12 plus R23 plus R31. From this 2 and this 2 will get cancelled. So R1 equal to R12 into R31 whole divided by R12 plus R23 plus R31. Very, very important. See here, if you recollect, this is the delta given. So this is between 1, 2, 3 and this is R12, R23, R31. Now this R1, this is R1, this is R2 and this is R3. Now this value which is in here, the what we will get emerge from here. This is R1 indirectly. This is R3. This is R2. Now to get this value R1, observe this is the product of these two. The product of R31 and R12. This is the product of R31 and R2 whole divided by sum of all. Whole divided by sum of all. Like that you can remember. Similarly, you can guess what will be the value of R2. For example, this R2, it will be the product of these two. At this point, which two resistors are joined? R12 is joined, R23 is joined. So your R2 will be in terms of R12 and R23 whole divided by sum of all. Similarly, if you want R3 at this point, if you want R3 at this point, which two resistors are joined in delta? R31 and R23. Like this you can remember. So your R3 will be product of these two. Product of R31 and R23 whole divided by, for all the cases denominator will be same, R12 plus R23 plus R31 only, but the only thing which changes is numerator. Now how do you remember? What is the easy way to remember that numerator? Simple. If you want R1, you see here at which point, that point two resistors are joined, no? You multiply those two values. At first node, which two are joined? R12 into R31. If you want R2, very simple. At second node, which two resistors are joined together? R12, R23. At third node, which two resistors are joined? R31 and R23. You multiply those two, divided by, denominator is same. Of course, this is the way for you I am telling you to remember, just to remember, not for derivation sake. While doing the problems, you won't do all this derivation and then you will decide, then you will find the formula R1 and later you do the substitutions. No. Somewhere in the middle of the problems, if you want to find out R1, then this formula should be memorized by you, right? Similarly, now if you do 6 minus 9, you will get R2 minus R1. R2 minus R1. And you just add up with 3. Adding with 3, you will get 2 times R2. 2 times R2. Now we want the value of R2. This two get cancelled. Now your R2 is R12 into R23 divided by R12 plus R23 plus R31, right? Similarly, now 10 minus 9, this is 10 is R1 minus R3 minus 9 is R1 plus R3 equal to, this is from 10, you cancel out, 2 cancel, you take out LCM, and we will get R3 as R23 into R31 whole divided by, denominator is same for all the cases, R12 plus R23 plus R31. So dear students, what I want to tell you is, for example, if you are given a delta like this, and if you want to find its star, while finding R1, it is a product of these two, denominator same. If you want R2, observe, it is the product of these two at second node, R12 into R23 whole divided by. If you want R3, it is the product of these two, right? For example, it is not a rule that everybody should give the numbering as 1, 2, 3. For example, somewhere you are given a problem like this, right? This is RAB between nodes A, B and C. This is RBC, this is RCA, this is node A. Now I want its equivalent star, RA, RB and RC, right? And this is node A, and this is node B, and this point is node C. So if I want RA, simply you take product of these two. So now RA equal to product of these two, RAB into RCA whole divided by, denominator is same, RAB plus RBC plus RCA. If I want RB, observe, RB will be here at this point, equivalent star. You take product of these two. Now RAB into RBC whole divided by RAB plus RBC plus RCA. Similarly, I want RC. Now at this point, its equivalent star, RC. You take product of these two. So what are those two? Or which two resistors are joined there at node C? RC equal to RBC into RCA whole divided by RAB plus RBC plus RCA. This is what you can do. Clear? Right? Yeah. This is how you can remember the delta to star transformation. Some people will discuss this topic in terms of ABC or in terms of some R by B, and some people will discuss in this topic in terms of 1, 2, 3. Anything is okay. Based upon which thing you are feeling convenient, you remember those formulas, right? But at last your target is to find out R1, R2 and R3. Okay, if you see the problem, then you will feel it is simple, easy. Once you do the problem, then, but most of the times in exams he is asking the derivation. Most of the times in so many question papers we have seen, he is asking express the given delta in terms of star. Derivations he is asking for 8 marks. Okay, or sometimes he will give you a simple problem like this and he will ask you what is its equivalent value in star connection. Like that also he will ask you. But not for final answer itself, you will be awarded the full marks for the procedure and the steps, and you should write the formulas and you should do the substitutions. Substitutions must be visible, formulas must be visible, right? And for all those things you will be awarded the marks. Now for example, if a problem is given like this, transform the given delta to equivalent star, right? So this delta, in this delta between 1 and 2, R12 is given as 20 ohm. Between 2 and 3, the value is given as 30 ohms, and between 3 and 1, R31, the value is 40 ohm. Now what is the value of R1, R2 and R3? That is important. Just now we have seen the derivation, right? From the derivation, what will be the value of this R1? Will be the product of these two. Simply take the product of 20 into 40 whole divided by sum of these three, 20 plus 30 plus 40. Very simple, very quickly you can do this problem, right? So 8.88 ohms. Now I want R2. So this R2 at this point, just take the product of these two, R12 into R23 whole divided by, what is the product of these two? 20 into 30 divided by sum of all. For all the things, your denominator will be same. Okay, your denominator will be same. 600 by 90, 6.66 ohms. Now I want R3. Right? This R3 at this point, what will be the equivalent star? That is product of which two resistors are connected? 40 into 30 into 40 whole divided by all those things, whole divided by 20 plus 30 plus 40. So it is 1200 divided by 90, 13.33. So what does that mean? This delta connection is equivalent to a star connected network like this, where R1 equal to 8.88 ohms, R2 equal to 6.66 ohms, and R3 equal to 13.33 ohms. Like this you have to do the substitution. Clear? This is what called delta to star transformation. Now let me do one more small example. For example, you please take down this example, dear students. It will be very helpful for you. You will understand it if you substitute the values and write down the formulas and indicate the node numbers, values of the resistors, right? Everything must be clear while attempting this question, such kind of questions in the exam. Not just without showing the calculation part, without showing the substitution part. And of course some people will do all these things, but they will do it in the rough paper or rough side, back side of their booklet. They will do all those things and they will directly write the answer. Then it will not give the impression for the evaluator who evaluates your paper. Most of the times you know the concepts and the basics, but the thing is presentation will count a lot. For example, some students, they, even though they know all these steps, they will do in the rough work. We will observe some papers, a lot of their hard work they will do in the rough pages, rough side or back side of their booklet. They won't show those things in a step-by-step manner in the answer script. If you show those steps as a step-by-step manner in your answer script or booklet, then the evaluator will get the impression, or he will know that you have tried that problem, you are doing that problem. I repeat again, this formula, if you write for this problem, if you write these three formulas itself, you will be given 3 marks. Minimum 3 marks will be awarded. Whether you got this answer or not, that is secondary. On drawing these diagrams, indicating the variable names and writing these formulas, showing the step-by-step substitutions, these things, your presentation style counts a lot, right? Yeah. Now, dear students, let me observe one more problem. For example, if this problem is given an example, some people may roughly do it in a rough work. Immediately fastly they will do 3 into 3 whole divided by 3 plus 3 plus 3, 9 by 9, it is equal to 1. Simply they will write 1 ohm, 1 ohm and 1 ohm. Okay. Of course they know the answer. At the same time, dear students, you show the procedure also, or you show the formulas, substitutions, calculations, and then final answer, instead of showing directly the final answer, right? Yeah. Now, for example, 3 resistors are connected, but here in this context 3 resistors are of equal value. RA is same, RAB is same, RBC is 3 ohms, RCA is 3 ohms, right? Now we know I want this value RA here, this resistor value, and I want this resistor value. If it is transformed into a equivalent star, I want this resistor value. This is what the meaning. So this delta is transformed to star. If I want this resistor value, you take multiplication of these two. If I want this resistor value RB, you take product of these two. If I want RC value, you take product of these two values. So simple. That is what we have done here. 3 into 3 divided by 3 plus 3 plus 3, 1 ohm. Similarly, RB, product of RAB into RBC whole divided by RAB plus RBC plus RCA. 3 into 3 divided by 3 plus 3 plus 3, you will get 1 ohm. Similarly, RC, we will get 1 ohm. What do you mean by that? How do you, one conclusion you can draw? If 3 equal resistors connected in a delta manner, in star manner, its value, its equivalent value is how much? 1/3. 1/3. It became 1/3 in star manner. If it is 1 ohm in star connection, okay, 3 equivalent resistors of 1 ohm each connected in star manner. If you ask its equivalent delta, then it will be around, it will be 3 ohms. 3 times you will get that value. 3 times the value in star, right? So this is how. Keep in mind, if only all the resistors are equal in magnitude, if all the 3 resistors are equal in magnitude, don't misunderstand here. For example, 3 different values are given in equivalent star. Don't write 1/3 of each resistor value. That will be not the answer. Don't understand like that, right? If all the 3 resistors are equal in delta, its equivalent value will be 1/3. For example, instead of 3, if he gave you 9, 9, 9, 9, then in your star how much you will get? 3 ohms, 3 ohms, 3 ohms you will get, right? Yeah. So dear students, this derivation is important, and these problems are important. Either you can follow 1 2 3 notation or ABC notation, or some people will follow R Y B notation. That is also okay. But whatever might be the notation, you remember how to transform the delta to the star. The thing is very simple. Simply to say in one word, if I want R1, I will multiply these two. If I want R2, I will multiply these two. If I want R3, I will multiply these two. Divided by base is same, denominator is same for all the things. Sum of these 3 resistors. Very quickly you will get the answer. Right? Thank you.